This is the review packet that we are working on today in our video. It says Thursday and Friday on it, and this is the measurement and data portion, measurement and data review portion. So we're going to start with this question right here. We'll do a few problems and then you'll do the rest of them tomorrow. So this question, I'm pretty sure, was on your measurement test, converting measurement test, the same exact question. So you should be fairly familiar with it. So it says the chart shows the distances that students live from school. Which student lives the longest distance from school? We have miles, feet, yards, and feet. You cannot just say this is the largest, Sam's the largest, because miles is larger. You cannot say that this is the largest because it's 47,000 and it's the biggest number. You cannot compare miles, feet, yards, and feet. They all have to be the same. Since two of them are already in feet, it would make the most sense to convert the other two into feet. So we would convert 7.5 miles to feet. You should know that there are 5,280 feet in 1 mile. The numbers are diagonal, so we're going to multiply 5,280 times 7.5. 5 times 0 is 0, 5 times 8 is 40, 5 times 2 is 10, plus 4 more is 14, 5 times 5 is 25, plus 1 more is 26. When I scoot over to my tens place, I put a 0. 7 times 0 is 0, 7 times 8 is 56, 7 times 2 is 14, plus 5 more is 19, 7 times 5 is 35, plus 1 more is 36. We add our partial products, 0, 0, 10, 16, 6, 7, 8, 9, 3. Now we need to put a decimal, since there's a decimal in our product, or in our factors, there needs to be one in our product, so it goes there. And if we back up 3, that's 39,600. So this was Mr. Sam, 39,600 feet. We need to also convert yards to feet. So 14,080 yards is blank feet. We should know that there are 3 feet in 1 yard. The numbers are diagonal, so we're going to multiply again. 14,080 times 3. 3 times 0 is 0. 3 times 8 is 24. 3 times 0 is 0, plus 2 more. 3 times 4 is 12. And 3 times 1 is 3, plus 1 more is 4. So that was Miss Leslie, was 42,240. Now that they are all feet, I can see that Andy was the smallest, the shortest distance with 21,000. Then it was Sam with 39,000, Leslie with 42,000, and the longest distance from the school was 47,520, which was Mr. Jordan. You have to show all of your work. This next question was also on your measurement test, so this should be familiar with you. It is good practice. That's why we practice these questions over and over again. Lyle ran 5 yards, Oliver ran 4 yards and 2 feet, Tyler ran 2 yards and 4 feet less than Lyle. How many total feet did they run? So we need it in feet, and they all ran different amounts. So we have Lyle, Oliver, and Tyler. Lyle ran 5 yards, but I don't want it in yards, I want it in feet. There are 3 feet in 1 yard, so I'm going to multiply. So Lyle's is 15 feet. That should be an R. Oliver ran 4 yards and 2 feet. 4 yards. I want to convert that to feet. There are 3 feet in a yard, so I'm going to multiply 4 times 3 to get 12. But he also ran 2 extra feet. So I need to add that to my 12. So Oliver ran 14 feet. Then Mr. Tyler. Tyler ran 2 yards and 4 feet less than Lyle. So first, I'm going to take 2 yards and I'm going to convert it to feet. There are 3 feet in 1 yard, so I'm going to multiply 2 times 3, which is 6. But we also have this 4 right here, so I'm going to add that. So that's 10 feet. It did not say that Tyler ran 2 yards and 4 feet. It said he ran 2 yards and 4 feet less than Lyle. So I have to take Lyle's feet, 15, and Tyler's feet, 10, and subtract them. 15 minus 10 is 5 feet. So now we have Lyle's 15, Oliver's 14, and Tyler's 5. We need to add these together. 15 plus 5 is 20, plus 14 more is 34. So altogether, these 3 boys ran 34 feet. This is another question that was on our converting measurement test. Cruz loves to jump rope. He wants to beat the current record holder, Joey Matze, who holds the Guinness World Record for the longest jumping rope without taking a break. Joey Matze set the record by jumping rope during a marathon session that lasted 120,000 seconds. Cruz was only able to jump for 29,700 seconds. How many minutes did Cruz spend jumping rope? This part here, I don't even care about. This part here with Joey Matze, I don't even care about. They just throw this in there to try and confuse you. All it's asking me is to convert Cruz's time of 29,700 seconds and see how many minutes that is. Since there are 60 seconds in 1 minute, and these are directly across from each other, I'm going to divide 29,700 by 60. 60, 120, 180, 240, 300. I hope that's enough because I'm sort of running out of room. 60 won't go into 2, it won't go into 29. It will go into 297. 1, 2, 3, 4 times. 4 times 6, 60 is 240. I subtract and get 57. I bring down a 0, and I did not have enough multiples. However, I'm going to use my 6 times tables. 6 goes into 57 9 times. 9 times 6 is 54. Put our 0 there. I'm going to have to subtract, which gives me 30. Got to subtract down here. Bring down my next 0. That's something that a lot of people don't like to do, is bring down their next 0. And 6 goes into 30 5 times. So 60 goes into 300 5 times. And that is 300 with no remainder. So that is 495 minutes for Mr. Cruz. The next one, 4 friends measure the width of the sidewalk in front of their own houses. The width of the sidewalk in front of each of their homes is recorded in the table below. Maddie claims that her sidewalk is the widest because 2,438 is the largest number. Sabra and the others disagree with Maddie. Solve the argument by determining who has the sidewalk with the greatest length, the greatest width. So while 2,438 is the greatest number, we can't compare these because they're in different units. Since these are metrics, we need to use our King Henry chart. So I'm going to create one here, kilo, hecto, and yes, you should create one on your paper, deca, unit, under unit is meter, liter, gram, deci, centi, and milli. Let's convert them all to meters. So that means we're going to be moving to unit every time. So deci to unit, that's 1 hop left. So if I take my decimal and move it 1 hop left, that's 1.22. 3.6 is not going to change because that's already in meters. Now I have centimeters to convert to meters, so centi to meter, 1, 2 to the left. Take our decimal here and move it 1, 2 to the left, so that's 1.828. And then finally we have millimeters to meters, so that's 1, 2, 3 to the left. We take our decimal at the end and move it 1, 2, 3 to the left, and that is 2.438. Now we're looking for the one with the greatest width. So if we look in our ones place, we have 1, 3, 1, and 2. Which one's the greatest? This one, which was Mr. Alex. So Mr. Alex actually had the greatest width of the sidewalk. We're going to do 2 more questions and then we're going to stop for the day. First one that we're going to do is a line plot. So this should be familiar because we're working on line plots right now. The line plot shows the amount of sugar Greg used in 8 different cookie recipes. If there are 3 cups of sugar in his canister, how much sugar will he use to make all 8 cookie recipes? So we are going to add all of these measurements together. We're not just going to count 1, 2, 3, 4, 5, 6, 7, 8. No. We're going to put all of these together. So 1/8, okay, that's easy. 1/8. Here we have 1/4, 1/4, and 1/4. So that's 1, 2, 3 fourths. And then here we have 1/2 plus 1/2, that's 1 whole. Another 1/2 plus another 1/2, that's 1 whole. So that together would be 2 wholes. So we're going to save that 2 for just a minute. We're going to add these 2 fractions first. First, I need a common denominator, which is going to be 8. So that's not going to change. But this we're going to multiply by 2 over 2 to get 6/8. So this is 1/8 plus 6/8 is 7/8. But we also have 2. 2 plus 7/8 is 2 and 7/8, which is letter choice D. The last one that we are doing today, which 2 statements describe a strategy that can be used to find the volume of an object being described in each statement below? So this is talking about volume. Walk around the outside of a backyard that measures 150 by 80. If you're walking around the outside of something, that is perimeter, not volume. Cover a wall that measures 12 by 15 with wallpaper. That, when you're covering something, that is area, so that cannot be volume. Stack unit cubes to fill the inside of a shoebox. This has several keywords. First of all, we're filling something, and we have unit cubes. Both of those are keywords for volume. Cover the top of a cube-shaped box with a lid. So yes, we have a cube-shaped box. However, all we're doing is covering the top. Since we are covering it, that is area. Place unit cubes inside of a shipping box until the box is completely full. We have the keywords unit cubes. We have full, like we're filling it up. So this is also volume. Now we have not finished the entire measurement and data review packet, but that's all we're going to do today. And then we will finish the rest tomorrow. If you have questions, email me.